Namaste and welcome back to the JavaScript series. Today, my dear friends, we are going to continue from the discussion of the previous class and understand what is really meant by asynchronous JavaScript. The previous class we discussed what is synchronous JavaScript. Today I will help you understand what is asynchronous JavaScript. And asynchronous JavaScript is such an important concept. Only if you understand this, you will be able to perform operations such as fetching data from either APIs or your own file system in your computer successfully. It's only if asynchronous JavaScript you will be able to handle user input on your front end using concepts such as event listeners. It is only if asynchronous JavaScript you can understand how your website can load media such as files and images from the server without making the website stuck or frozen. It is only if you know this concept you will be able to understand the concept of timers and intervals. Overall, one of the most important concepts of JavaScript. So today, let's try to understand how asynchronous JavaScript works. But in order to understand how this asynchronous JavaScript works, first of all, let me give you a quick recap of what is meant by synchronous JavaScript, right? So I'm just taking you to my editor here. Okay, on my editor, please try to understand. This is a small piece of code I've already written, which I had already explained last time. See, try to understand. Imagine, okay, I'm just showing you what I'm talking about. Imagine this is the dashboard of Tap Academy's platform, which we call as Thai, right? In this platform, there are different elements, such as when you load the dashboard, you have to fetch the course progress, you have to fetch the leaderboard, you have to load the banner images, and all of these are activities which are independent of each other. But the nature of JavaScript is, it is a single-threaded, synchronously executing programming language, which means it only executes sequentially or step by step. And this is a big problem. Try to understand. See, I have three functions: fetch course progress, fetch leaderboard, fetch banner images. Now, what I'm trying to do is, I'm just trying to say, hey, dashboard loading has started, and then I'm fetching the course progress, fetching the leaderboard, fetching the banner images, then I'm saying the dashboard loading is completed. Now, the synchronous nature of JavaScript will ensure that when my course progress is getting loaded, the entire dashboard UI will get stuck, because neither can leaderboard be fetched, nor can the banner images be loaded, and nor can the user do any interaction because of the synchronous nature. And if you look at these functions a little deeply, you'll understand how this function is written is, say fetching course progress started, I'll have one statement. After that, I've created a loop which will inject some delay into my program. And I already explained the logic behind this. If you're coming directly to this video, you can just go back and watch the previous one and come to this, all right? So I think you'll understand what I'm trying to say, right? It will inject a delay, and the delay is going to be for 5 seconds, because here 5000 is in milliseconds, so the calculation is 5 seconds, right? Similarly, this 5 seconds where the course progress is getting loaded, in that 5 seconds the entire UI will freeze, and neither can any of these functions such as fetching the leaderboard nor the banner images, nothing will happen. It gets stuck. And to emulate this, what I'm going to do is I'm going to execute this for you. But to understand this, you should understand it from the memory point of view. So I'm just bringing up the call stack. All of you know that in JavaScript you have something called as a call stack. The first thing that happens in any JavaScript program's execution is the global execution context gets created within the call stack, right? And any statement which is outside all functions is what will be executing inside the global execution context, which means these lines. In that, when the first line executes, you will be getting dashboard loading started, right? After that, when you say fetch course progress, when you call this function, obviously its execution context gets created on the call stack. Now, please try to understand, JavaScript is called as a single-threaded, synchronously executing programming language. What does this mean? What it means to say is that on the stack, at any given point of time, only one thing can execute, never multiple things. Because in JavaScript, who is executing the contents of this call stack is a line of execution, which we call as a thread. A thread is nothing but a line of execution which is responsible for executing the statements within the call stack. And if you have only a single line of execution, we call this as a single thread. So it's single threaded, you can see. And the single thread can execute only one statement at a time. And that is why global execution context execution will pause, which means now the user can't use the dashboard. And now what will start executing is the fetching of course progress. And when I go to this fetching course progress function, you will get this statement now. Fetching course progress started, beautiful. After that, now there is going to be a delay of 5 seconds in which nothing else can happen in the UI. Nothing else can happen in the website, which gives a terrible user experience. Anyways, after 5 seconds of delay, once course progress finishes, you'll get this line fetching course progress completed. And once a function finishes its execution, it gets removed from the call stack. And the control goes back to where it came from, which is the global execution context, which is nothing but these statements. In that, this line was over. Now we will come to the next line, where now we are fetching the leaderboard. Again, you're calling a function, its execution context gets created. Now fetching leaderboard executes, and when this is executing, the dashboard part will freeze. Everything else will freeze, and you have to wait for however long this fetching leaderboard is going to take. And here also I have induced a delay of 5 seconds. So this is also going to take 5 seconds. In that 5 seconds, your entire UI becomes unresponsive. This finishes execution, it gets popped, control comes back to the global execution context. Next, fetching banner images, now that gets loaded. Again, when that gets loaded onto the stack, global execution context stops, in our case the dashboard, and again the user is stuck waiting for the images to be loaded. And only once it finishes and gets popped, then control comes back to the global execution context, then the dashboard finishes execution completely, that it gets loaded completely, then the UI gets unstuck or unfrozen and now you can use it, and then finally even global execution context goes. So you can clearly see execution happens only sequentially, execution happens only one line at a time, execution happens in a single threaded process or a manner, and when one thing is executing, the other thing cannot execute, it has to wait. So basically, one piece of code blocks the other piece of code. That is why JavaScript is called as a single-threaded, blocking, synchronously executing programming language. All these are fancy terms, but I hope you understood what I'm trying to say by that, okay? Any which ways, let's go ahead and just execute this and show you the output, right? So if I just bring up my terminal here, just a moment. If I bring up my terminal here and if I were to execute, now dashboard loading started, great. Now fetching course progress is happening, everything else is stuck. Once that gets over, then leaderboard gets started, everything else is stuck. Then once leaderboard finishes execution, now images are getting loaded. Now everything is stuck. Then finally after images, dashboard loading is completed. So this is that blocking part of JavaScript, synchronous part of JavaScript. Now this is not cool, right? I don't like this. See, ideally in every modern day website, if I am trying to load my images, doesn't mean that my dashboard should get stuck. You should still be able to use my dashboard, right? It should not block my piece of code. So what happens is all these are blocking codes. These are codes which will block the other code. But I want this blocking codes to execute in a non-blocking fashion. It must not be an obstruction to others. Non-blocking way it should execute. If you're taking 5 seconds, you take 5 seconds, don't affect my dashboard. Now how can we do that? You cannot do that if you just rely on the features that JavaScript gives you. Please try to understand JavaScript has been designed in such a way that it has only one thread. It can execute only synchronously. You can't change the nature of this programming language. Then what happened, you may ask? Then what happened, if you ask me, this is where the people who invented browsers came to the help and told, hey, listen, the JavaScript engine which has been given by the people who created JavaScript ultimately has two pieces of memory. One is your heap, other is your call stack. Heap is for objects, call stack is for the execution of your functions, and I've explained all this in depth. This is what the JavaScript engine natively gives you, understood? But then what happened is all your browsers such as Chrome, such as Internet Explorer, such as Firefox, what they did is they told, hey, listen, whatever is the limitation of JavaScript, I will take those limitations, and to overcome those limitations, I will give you an extra set of features which is not part of the JavaScript engine, which browser is giving me. And these features which the browser is giving me in order to overcome the disadvantages of the native JavaScript engine is what we call as web APIs. Is what we call as web APIs. Understood? Every browser gives you web APIs. What are web APIs? It's a set of functions and tools which you can use, which JavaScript will not provide for you. JavaScript is synchronous, but these people will allow you to execute in an asynchronous manner. Some of the web APIs that they have given. One is DOM feature, document object model, which we will be learning very soon. Another is the ability to set timers using SetTimeout, SetInterval. Other is the ability to fetch. For example, you want to fetch the data from an API. You want to interact with another server, APIs using fetch. And many other such APIs has been given to you, which we will not discuss now. We'll go into the depth. Also, they've given us two more data structures in order to make this asynchronous execution happen. One is called as the Microtask queue. Another is called as the callback queue. So all these days, your focus was only on this part. Now I am showing you the outside part. And please understand, none of these are the features of JavaScript. Who gave you these features? Browsers. What are they called as? Web APIs. And these features which the browser gave, they took it out of the browser. They took it out of the browser and said the same features outside the browser also, if you want, you can execute, which is what you call as Node.js. This is only Node.js also. Same features is what is available in Node.js. So if you're executing JavaScript within the browser, you'll be using web APIs that the browser gives you. And if in case you're executing JavaScript outside the browser the way we have been doing, we call it as Node.js. Ultimately, they're one and the same. I hope this is clear. Now it is using these web APIs that I will show you how you can be implementing asynchronous execution or non-blocking execution. And how are we going to do that? Let me show you. Now let me take a simple example to show you how using the web APIs provided by the browser and Node.js, we can actually achieve asynchronous execution of JavaScript. I'll just bring up my editor here for your reference, and I'm going to write a very simple program, okay? So watch it. I'm just going to create three functions, my friend. I'll call this function as fun, right? I'll just copy this. I'll paste this 2 more times. I'll change this to fun. I'll change this to fun. Now, what am I trying to explain? Now, fun and fun, they can execute sequentially or synchronously. I have no problem. But this fun is going to take some time. And because of the time that it is going to take, I don't want it to block these other guys. So I want this person to go away from my stack somewhere else. And there let it take how much ever time it wants. And only once all these synchronously executing code is done and when the stack is free, that time it should come and execute. If you didn't understand what I'm saying, let me show it to you visually. First of all, let's complete this code. I'll just go here and I'll put a simple statement, okay? What are you going to do if you ask me? Let me just change this 1 second. Yeah. So here, I'll just go and say console, and inside this, sorry, oops, my keyboard is acting weird. Yeah. So here I'll just go and say probably fun execution started. Great. Next, let me just duplicate this line and I will say fun execution completed like this. Next, what I'm going to do is I'll copy the same 2 lines, paste it here. I will change this to probably fun execution started, execution completed. Similarly, I'll go here, paste it inside fun as well. And I will just change this to fun execution started and completed. That's great. Now in between this fun, I'm going to add some delay. And the code for this, you already know it, so I'm just going to quickly write it. I'll just figure out what is the start time by saying date dot. Next, I will be setting a particular delay. I want 5 seconds, so in milliseconds, I'll say 5000. Next, I will be creating an end, which will be nothing but the start time plus the delay. After which, I am going to be creating a very simple while loop in which the condition is going to be as long as the end or the current time, that is date dot, is lesser than or equal to the end time. As long as that is true, I want to keep looping. So basically, this will generate a delay of 5 seconds. That's it, long story short. There is no such delay in fun, right? Now, all of you should watch it. If now I just go and mechanically say fun, I'll call first, fun, I'll call second, fun I will call third. See, now what happens is, you must try to understand, I have my call stack here, right? I have my call stack. Now try to understand, now what happens is, how JavaScript natively has access only to the call stack. Call stack is single threaded, which means now if I were to execute this piece of code, if I clear the previous output, now what will happen? First, please tell me which function am I calling? I'm calling fun. So first of all, global execution context gets created. Inside that, these three statements will be there. In that, when I call fun, execution context gets created. Now when fun is executing, no others can execute, no problem. Fun1 will execute quite fast. It will say execution started, execution completed. Next, fun execution context goes, control comes back to the global execution context, in which now I'm calling fun. Now when fun gets called, its execution context gets created, but this is where things get interesting. I'll get fun to execution started, but now for 5 seconds there's going to be a delay. During this 5 seconds of delay, my program execution is literally halted or is frozen, because now, though fun is there, it cannot execute because fun is the blocking code now. It will block the execution. This is what I don't want to happen. Anyways, after 5 seconds, fun will go, then fun3 comes, fun will immediately execute, fun3 goes, global execution context also goes. But I hope you understood that blocking part. And it's the same thing which I'm showing you here. Fun1 started, fun2 execution started, but now it is blocking the execution. But once it completes, fun quite quickly finishes. Now this is not what I want. Now see the magic of asynchronous execution. Now to understand how asynchronous execution works, I'm just going to minimize these function bodies because I don't think you really need to see them. And now here, let's understand from the memory point of view. So first of all now, the JavaScript engine has only call stack. But now I will take the help of the browser's web API, which comes with its own two data structures, Microtask queue and callback queue. Now, in order to asynchronously execute the code, JavaScript uses a concept called as event loop. Now, what is this event loop? Try to understand, right? So, event loop is basically a program which is silently executing in the background, which helps in achieving asynchronous execution. Now, watch what happens. So, now, what I will do is, I want this fun to execute, but not synchronously in my call stack, asynchronously. So what I'll do is, I will now take this fun and instead of directly calling it, browser has now given me something called as a timer API, inside which it has given me multiple functions, out of which one function I want to show you, which is called as the SetTimeout function. What is the name of the function? SetTimeout. SetTimeout doesn't belong to JavaScript. SetTimeout belongs to the web APIs of the browser or Node.js. What SetTimeout does is, it takes two arguments. One is a callback function that needs to execute at a later point of time, which will otherwise block the code. Second is a timer. Now try to understand how this works, okay? So what I will do now is, tell me which is the function you want to execute later fun to. So I will pass fun as a callback. And if you have any confusions with respect to callback, go back in this playlist and rewatch the videos where I've explained callbacks in depth. See, now we are reaching a point where all concepts start to get combined together. So make sure you're revising. Now, fun is clear to all of you. So the callback is fun. Next, I'll give a timer. Let us assume 2000. Again in milliseconds. Here its meaning is 2000. Now what exactly happens? Try to understand. When JavaScript begins execution, first thing that happens is my global execution context gets created, inside which have these three statements. In that, when this statement executes, fun1's execution context gets created. Fun1 begins execution, and fun1 is a very simple function in which I have fun1 execution started, fun1 execution completed. Quickly it finishes its execution context gets deleted, control comes back to the global execution context. Now try to understand, when I say set timeout, on this call stack, set timeout's execution context will not get created because it doesn't belong to JavaScript. It belongs to my web APIs. Now, when you say set timeout, please try to understand, the browser is going to basically make a note, or it is going to register. So I'm just showing you, it's going to register or make a note that the programmer wants to execute a callback function called as fun2. Not right now, later. Later when? After how many seconds? 2 seconds. Immediately it will put a timer in which it will make a note 2 seconds. And the timer will start now its countdown. Understood? Slowly, because 2 seconds is too low. I'm not showing the countdown. I'll come to it, but it'll make a note that it has to execute fun, and after a timer of how much? 2 seconds. Now what happens is, please focus on the call stack. When I called fun, did it create its execution context here? No, which means fun was not executing on the call stack, which means call stack is not getting blocked, and hence immediately control goes back to the next line, which is fun execution context gets created. And once fun execution context gets created, it will quickly say fun execution started, fun execution completed. That's it. Understood? Now it gets popped. Control comes back to the global execution context. There is no more functions remaining here, right? Now global execution context also goes. Now try to understand, while all this was happening, in the background this counter was slowly decrementing. 2 seconds became 1, 1 became 0. When it becomes 0, what happens? The event loop comes into the picture. The moment the counter becomes 0, event loop takes this fun function and adds it to a data structure called as the callback queue. It adds it here. Understood? Next, event loop will keep scanning the call stack and it will check, is the call stack empty or not? If anything is executing in the call stack, it will not touch it. But the moment call stack becomes empty, event loop notifies that now the stack is empty, whatever we want to execute can be executed. And hence it takes the function which is there inside the callback queue, adds it to the call stack. And now fun execution context gets created. And now fun begins execution. And when fun begins execution, you can see naturally it is going to take 5 seconds to completely finish, but that is totally fine with me because clearly you can see fun is not blocking the execution of anything else because the stack is literally empty. I hope you're able to understand. Now tell me, synchronous execution means what? Line by line. First fun should have executed, then fun should have executed, then fun should have executed. But now, because of the web APIs, because of the timer functions such as SetTimeout, we have broken the normal flow of execution from fun1, fun3 to fun1, fun3 and then fun. Fun2 did not block the execution of the others. If you don't believe me, let me show you the output. Watch this carefully. Upon execution, fun started, completed. Fun started, completed. Then fun started. After 5 seconds of delay, it finishes execution. Asynchronous execution, non-blocking way of executing. All this possible through the web API features of the browsers, or in our case, Node.js. Because how am I executing this? Node.js. What is Node.js? JavaScript plus the web APIs bundled together, which you can execute outside the browser in something like VS Code. That's all Node.js is. Understood what I'm trying to say? So, couple of points here which I feel you should understand. See, first of all, when you said set timeout, this 2 seconds is not the delay. Don't think that after 2 seconds this will execute. It is not like that. After 2 seconds, it will add it to the callback queue. When it will execute, totally and completely depends upon whether the call stack has become empty or not. The call stack may become empty after 2 seconds, it may become empty after 10 seconds, after 2 minutes, we don't know. Only when it's empty, it gets executed. But to get added to the callback queue, the timer is 2 seconds. So this is not the time or delay for it to execute. Do not ever get it confused. Now, because this is such an important concept, I'm going to do one more example where I'm going to try to execute 2 functions asynchronously, 2 functions synchronously. And then you will understand exactly what I mean by how the event loop works, right? Anyways, let me show you the next example. Now, this is probably the most important example of today's class. If you understand this one example, I can guarantee you have understood the concept of asynchronous execution, web APIs, and set timeout properly. So listen to me carefully. I have now 4 functions with me. Function 1 is very simple, no delay, nothing. Function 2 has a delay of 5 seconds to finish execution. Function 3 also has a delay of 5 seconds to finish execution. Function 4 on the other end has absolutely no delay. So basically, clearly you can notice function 1 and function 4 are non-blocking code. They will hardly take any time to execute and they are not going to block anything as such. But function 2 and function 3, which is a time-consuming activity, is definitely going to block the code. So these two should execute synchronously and these two should execute asynchronously for me, right? How? Now what I will do is, watch it, I'll come outside and see how I will now do. Fun1, I will call it normally. When you directly call fun like this, it will execute on my call stack. But fun should execute asynchronously. So you pass it to the web API of the browser. How do you do that? Using a function given to you called as SetTimeout. In SetTimeout, you should pass 2 things. First is the function that you want to execute later or callback. Which is the callback in this case? Fun. Next is the timer component that you need to give. Now you'll understand this timer correctly. I will give this timer as probably 5 seconds. That is 5000 milliseconds. Now even fun has to be executed asynchronously, correct? So I have to call SetTimeout. So watch it, I'll just duplicate this line. I'll again call SetTimeout. I'll pass fun3 and this time I'll give 2000 as the timer component. Next, fun4 can execute directly. So no problem, I'll call it like this. If this is clear to you, everybody should focus how this works. I'm bringing the complete memory diagram in front of me. Now all of you should focus. First things first. On the call stack, global execution context is created. Inside the global execution context, the first line is you're calling fun. You're calling it directly. Obviously, it's execution context that's created within the call stack. Now, inside the call stack, global execution context will stop. Fun will start executing. And you know what is there in fun1. There is hardly any code in it. You will get started, completed. Its execution context goes. Control comes back to global execution context, in which now when you call SetTimeout and you pass fun2, it will not execute now on the call stack. Instead, now here it will make a note that programmer wants to execute fun2 and the timer associated with it is what? 5 seconds. 5000 is 5 seconds. It will not execute now. Next line again you're saying SetTimeout. Hence fun3 will not get called on the stack. Instead it will make a note inside the web API that hey, programmer wants to execute fun3 and what is the timer? 3 seconds. Now this 5 seconds and 3 seconds automatically countdown will be happening. I'm not showing it here, but countdown will be happening. Now try to understand. Now control comes to next line. You're calling fun4. You directly called. Obviously it gets created within the call stack. Fun4 will quickly finish execution. Control comes to the global execution context. Do you see any more lines? No. No means now this global execution context also gets cleared. In the meanwhile, this countdown was happening. 5 was becoming 4. 3 was becoming 2. Like that, countdown was happening. When countdown is happening, tell me, will the 5-second timer finish first or 3-second or 2-second timer finish first? Obviously 2-second timer will finish first. Whichever timer finishes first, that function gets added to the callback. And in our case, which is the function which will get added to the callback first? Fun3. After fun3, what gets added? Fun2. Please try to understand. Yes? Now, the event loop's job is to continuously monitor the call stack and see whether it is empty. The moment it is empty, it comes to the callback queue and sees whether there are any callback functions ready to execute. Yes, there are 2 functions, but the name itself tells queue. The nature of queue is first in, first out. First in, first out. Who comes first in the queue only exits the queue first, right? Or FIFO, what we call it as. Because of the nature of first in, first out, tell me which is the first function which came. Was it fun3 or was it fun2 or fun3? In this case, fun3 came first, fun2 came later. And hence it will now take fun3 and put it inside the call stack. Its execution context gets created, fun3 and its execution. Naturally, fun3 is going to take 5 seconds to execute. After 5 seconds, once it finishes execution, it gets removed from the call stack. Again, event loop will see call stack is empty. Come to callback queue, see whether there are any functions ready to execute. Yes, who's ready to execute now? It is none other than fun2. Now fun2 gets called. Fun2 starts executing. Obviously, it will take some 5 seconds to execute, after which it finishes. Execution is done, its execution context gets removed. Now event loop will check, is there anything else in the callback? No, nothing, program is finished. So just because I called fun2 first and fun3 second while writing the code doesn't mean that fun2 will execute first, fun3 will execute next. It literally depends upon the timer, because it is the timer that decides when it gets added to the callback queue. And when it gets added to the callback queue literally decides when it gets executed. Because people don't learn JavaScript, this is why they're utterly and totally confused always when they try to advance to larger topics. Great. So if this much is clear to you, let's experiment and see whether our execution is right. If I were to execute, fun1 execution started, completed. Fun4 execution started, completed. Then who came first? Fun3 came first. After fun3, who came? Fun2. And that clearly you can notice here. First fun3, because 2 seconds timer. That is why after fun4, fun3. Then only fun2, because 5 seconds time. So perfectly it works. And you will get many such questions in the interview where you are expected to basically guess the output. And you will never be able to guess outputs like this because you never understood JavaScript like this. Now naturally I know there is one question. The question is, what is this Microtask queue? Now when it comes to asynchronous execution, we have something like SetTimeout through which you can do. And you also have something called as async, await and promises, which also I will be covering. When promises come into the picture, Microtask queue comes into the picture. What I mean by that, I will explain all of that to you, don't worry, but I hope this much is clear to everyone. All right, so in order to complete today's discussion and conclude it, there is one last thing that you need to know, which is something called as SetInterval. Like SetTimeout, you have something called as SetInterval, right? Now try to understand the use case of SetInterval. So let us assume like this, I have written one simple function called as fun. And let us assume in a real world scenario, this is a function which has to constantly keep fetching data from a server. So let us assume you're watching the live streaming of some sports event, right? Now the score keeps changing dynamically every minute, right? You're watching a football match, something keeps changing. So every time, let us assume every 2 seconds, it has to reach out to the server, fetch the latest data and populate it in the front end for you. So this has to keep repeating every 2 seconds. But if I execute this sequentially, it will block all the rest of the code there. So the best way to execute this is asynchronously, correct? Now how are we going to do that? And I want to execute it asynchronously in such a way that it has to keep executing every 2 seconds. Now how do we do that? That's very simple. That's one of the use cases of SetInterval. Now SetInterval also is something which your web API is giving to you. It's not there natively within JavaScript, okay? So try to understand. I'll just minimize this so that you can understand it. I'll just go here and I will be calling SetInterval. Now SetInterval basically takes 2 parameters. First one is the callback. The callback here is nothing but the function called fun. The second is how many seconds do you want to keep repeating it? Let us assume I want to keep repeating it every 2 seconds. So I'll go and give 2000. 2000 is in milliseconds, which converts to 2 seconds. Now try to understand how this works. When execution begins, the global execution context gets created. Within the global execution context, when this first line executes, now this is not a JavaScript function, this is not a synchronously executing function, this is an asynchronous function given by the web API. It will not get created on the call stack. Instead, inside my web API, now it will make a note that programmer wants to execute the fun function, okay, every 2 seconds. So one counter starts. Now the moment the 2 second counter becomes 0, it will take that fun function and add it to the callback queue. And now SetInterval is different from SetTimeout because now it will reset the timer back to 2. Understood? Again, the moment it becomes say 0, it will add it. Again, it will reset the timer to 2. If it becomes 0, it will keep adding the function to the callback queue. Now, adding to the callback queue and execution are two different things, because execution of the functions in the callback queue will only happen once the call stack is empty. So obviously after this, the global execution context will be popped out. Now that the stack is empty, event loop comes into the picture and picks the first function in the callback queue, puts it into the stack. It executes. When it executes, what is executing? This function. What is there in this function? Fetching data, one message. Now it will finish execution, it will pop out. The next one gets added from the callback queue. Again the same function, fetching data. It gets removed. Again the next function gets added. And please try to understand, every time a function is getting added and it is executing and it is getting removed, on the other end I hope you're noticing functions are continuously getting added every 2 seconds. This will not stop, it will keep running. So watch it. If in case I were to go here, I were to clear this code, and if I were to re-execute it, you can see it will now say fetching data. Again 2 seconds later, fetching data, fetching data. So it will keep asynchronously executing in the background. It will not block any code. Only when the stack is empty it executes, right? But one more thing you can notice is it will not stop. So how do you ensure this stops? So here I will force quit it by just pressing Ctrl C like this, it will stop it. But what I want to essentially do is, I want, let us assume, this function to completely stop execution after 10 seconds. So for 10 seconds it can keep executing every 2 seconds, but after 10 seconds you should stop. How do we do that? Please try to understand. Whenever you call SetInterval, it will give you one value as output or as a return value. That value, I will collect it inside a variable called as interval ID. So every SetInterval function, please try to understand, has an interval ID. It is this ID through which you can identify this function within the web API. Understood what I'm trying to say? Now once you have this interval ID, there is another function which the web APIs have given to you called as clear interval. Using clear interval, if you pass the interval ID, it will stop its execution immediately. Now how are we going to do this? Now try to understand. I want clear interval to stop the execution of SetInterval function after 10 seconds. How are we going to do this? So first of all, try to understand. I'll come here now and I will be calling clear intervals. Clear interval takes only one parameter, which is an interval ID. So whatever interval ID I have, I will just pass it. Understood? Now what happens if I just do this much is, the problem is I want you to look at the output. If I start the output, nothing happened because SetInterval got registered. 2 seconds later it should begin its execution. But immediately next line, clear interval cleared the interval ID and removed it from the web API. So it didn't even execute once. Now how do I tell clear interval? Clear interval, please you wait for 10 seconds, then you clear it. But clear interval can take only one parameter. Now there is a workaround around this. The workaround here is something like this, wherein I will pass clear interval into SetTimeout. Because SetTimeout can have a parameter of time, say 10 seconds. After 10 seconds it will execute clear interval, right? Now how are we going to do that? This syntax is something everybody should focus, otherwise you will get confused. Now watch it. I will call SetTimeout. Sorry, not set. I want to call SetTimeout. Now SetTimeout takes two parameters. One is a callback, another is the delay. I'll put a comma. The delay is 10 seconds, so 10,000 because in milliseconds. The other one is a callback. Now in the callback, see what I will do. Everybody knows there is a syntax called as arrow function syntax. I hope everybody remembers this syntax. Arrow function. Right? There I will now go and I will now be saying clear interval like this. And here I will be passing my interval ID. So please try to understand. I'm calling SetTimeout. For that I'm passing a callback function because the function doesn't have a name, the function has only a single line body, doesn't have any parameters. The easiest way for me to write that function is as a callback. So there's a callback function or arrow function. In the arrow function, I'm saying what is the body of the arrow function? Just one statement, clear interval. To clear interval, I'm passing interval ID. When will this callback function be executed? Only after 10,000 milliseconds or 10 seconds. Which means when this first line executes, this guy will start executing every 2 seconds. Once 10 seconds elapses, interval, this clear set timeout will ensure that this callback function executes. What is there inside this callback function? Clear interval. Clear interval will clear this interval ID, and after 10 seconds this will stop. Understood? Now, if I just were to go here and clear the screen and re-execute, you can see now it will say fetching data. Once 10 seconds elapses, clear interval will clear it, and once it clears it, it stops. Understood what I'm trying to say? So I hope you understood that set interval will keep repeating it. Clear interval will clear it. Okay? And in order to ensure the clear interval will clear it after a particular time, the workaround is to put it inside SetTimeout. I hope this much everybody has been able to understand. Today was a very important class, and I hope all the concepts you've been able to absorb. Anyways, if you enjoy these classes, make sure to like, subscribe and comment, and stay tuned for even more amazing videos which is upcoming in the JavaScript series. Thank you so much. Bye-bye.